So I just wanted to have us practice a few more problems. So if you'll turn to the page that looks like this, factoring trinomials, a equals 1. If you don't have paper, just write the problem down. We're going to start with number 4. And what I would recommend is, if you remember how to do it, pause the video as I'm doing it, and then you can go back over and see if you did it right. If you need to watch for a while, that's fine too. So here we go. Remember with this, what we're going to do is we're going to start off by taking a times c. A here is 1, so we're going to take 1 times negative 12. And we get negative 12. We're going to put that at the top of our x. We have to make the x. And then we put b at the bottom. We want to find the factors of 12, okay, in pairs. So 1 and 12, 2 and 6, 3 and 4. Now we notice that we have a negative. So if I have a negative up here, that means my signs are going to be different. Well, which one's going to be negative, which one's going to be positive? In order to find that out, we look at b. If b is positive, then our larger factor is going to be positive. So that means our smaller factor has to be negative. And again, the reason for that is because what we're going to do with these is we're going to add to find out which one gives us 4. So when I add here, I get a positive 11. See, I get a positive. Here I get a positive 4. Now here I have a positive 1. I don't need it because I already found it. But that gives me a positive 1. So now we're going to put a negative 2 and a positive 6. We now write out the factors, we now write out the trinomial expanded form. So n squared, and in place of 4n, we put negative 2n plus 6n, and then minus 12. So we just have taken the 4 and we've expanded it with these two numbers here. We're now going to factor by grouping. So again, what we do is we take the greatest common factor out of the first two terms. That would be n. So I have n minus 2 left. Greatest factor out of these two would be 6. Divide by 6, I get n minus 2. And of course, what's in the parentheses is the same because we did it right. Yay! So now my greatest common factor, I continue to factor by grouping. Greatest common factor again is n minus 2. What do I have left? N plus 6. And that's my final answer. So hopefully that brought back some memories. Now I'm going to go right into some harder ones. Well, actually I'm not. I'm going to skip ahead to a couple pages. Factoring trinomials, day 2. We're going to try these two together, and then we'll go do some that are a little more complicated, just so that then we have that experience. Oh, nope, I'm not. Yeah, I am. No, I'm not. Okay, sorry, changing. So, number 4, actually on the next page, factor trinomial. So go back to factor trinomials. We're going to do number 4. Okay, so on number 4, here we go. We're going to do the same thing. We're going to take a times c. So 5 times 12 is going to give us 60. We put that up at the top of our x. And of course, 19 goes down at the bottom. We want to find the factors of 60. 1 and 60, 2 and 30, 3 and 20. Does 4 go into it? So we take our calculator, 60 divided by 4. It does. It goes in 15 times. 5 goes into it 12. We just did that. 6 goes into it 10. Does 7 go in? Nope. Does 8 go in? Nope. Does 9 go in? Nope. So we know we have all of them listed because there are no factors between these bottom two. And that's the reason I think it's really helpful if we do these in order. Now, remember, sometimes not all these numbers will be here. 60 is just unique in that way that it was. Okay? So now we have to find the pair. Oh, we forgot to look at this. This is positive. So if this is positive and this is positive, all my signs are the same. They're all positive. So which pair, when added, gives me 19? You've already found it, I'm sure. 4 and 15. Okay, we're now going to write this in expanded form. So 5n squared plus 4n plus 15n plus 12. Factor by grouping. Greatest common factor here is n. Greatest common factor here is 3. Now, if I want to remember that, remember I can go back over here. So I was looking at those and go, what's the greatest common factor? If my mind is glitching, take this first number. Does 5 go into 15? Yes, 3 times. Okay, so 3 is probably my greatest common factor here, so I can divide them both by 3. So use that to your advantage. You know you want to come up with the same thing, so use that to your advantage. Okay, now the greatest common factor here is 5n plus 4, n plus 3. Okay, so hopefully you're remembering it. I want you to turn to the next page. And I picked these on purpose because they're going to come out with some really big numbers. So grab your calculator. We're going to need that too. Okay? So here we go. We're going to take 6 times negative 49 and we get a negative 294. Now, who wants to list all the factors for 294? Raise your hand. Yeah, nobody does. So we're not going to. Now we're going to do everything else the same. So negative 294, and we want 7. So we know that we have to have them kind of close together in order for this to work. So we're going to look at what goes into 294. We know 6 and 49 does. So what we might do is pick something close. 6 and 49 does not. We have to know that when they're subtracted, this is a negative, so my signs are different. My largest factor is going to be positive. So we'll keep that in mind just a second. Okay, so now let's just try some things. So take 294, so I'm just going to take my calculator. 294 divided by 12. I a lot of times start off by 12. That gives me 24.5. That's not going to work. 294 divided by, I don't know, what do you want to try? 14? Oh, 21. 14 and 21. Oh my gosh. So I picked 14 because I went up from 12. I knew 13 didn't go into it because it was even. I tried 14, and look, they're 7 apart. Oh my gosh, did I just get lucky or what? Okay, if I believed in gambling, I should go out and buy a lottery ticket. Not going to do that right now. Okay, so that means my larger factor has to be positive, so I get a negative 14. When I add those, I get a positive 7. Wow, did I get lucky. But do you see what I mean? I took my calculator. I tried different things. That's what you're going to do too. When you have big numbers, when it's over 100, just try different numbers, okay? Unless you know them. Okay, so I'm going to use negative 14 and positive 21. So I get 6x squared minus 14x plus 21x minus 49. Then I'm going to factor in by grouping. So I'm going to take greatest common factor here would be a 2x. So I get 3x minus 7. Greatest common factor here. Now again, what I was saying is if you don't see it right away, look at this. We know that 3 has to be part of what it is. So if I take 3 into 21, I get a 7. Does 7 go into both of these? Yes. That's my greatest common factor. So use this to your advantage. So I get 3x minus 7. And yay, we have the same thing in parentheses. If we wouldn't have, again, we'd have to go back and get a different greatest common factor. So what they have in common is 3x minus 7. What's left over? 2x plus 7. Okay. Number 16, I'm going to tell you something, and then you're going to try this one on your own. You're going to stop the video and try it. Okay, so on this one, see how that front term is negative? We never want it negative. We'll talk about that later on. But if you ever have a negative, you're going to have to factor out a negative. So I'm just going to go ahead and do it. I'm just going to change this problem, actually. So I'm going to change it to have everything be positive. 6a squared plus 25a plus 25. Okay, so I'm actually changing the problem because if I have a front term, a leading coefficient that's negative, I'm going to have to factor it out. We'll deal with that tomorrow. Okay, now we're going to multiply 6 times. Oh, now you're going to pause it. You're going to pause and try this one on your own. So hopefully you've had a chance to try this one on your own and you're just coming back to kind of check to see how things are. If not, and you got stuck, great time to come back. So I took 6 times 25. I got 150. That goes at the top of my x. 25 at the bottom of my x. So now I'm going to find factors of 150. And no, I'm not going to list them all. So I'm going to start with the obvious. Does 10 go into it? Yes. 15 times. So I always start with something right around 10, 12, 13, something right around there just to get me started. Now, this top is positive and this is positive, so my signs are the same. So when I add, again, this was a nice one. It came out so easy. So on this one, we notice that it's a 150 and a 25. This one came out pretty nice. It was just 10 and 15. But again, I usually start around 10 or 12 or 13 or 14. We get 25. So this is what it's going to look like. So if you haven't had a chance, now that I've shown you that too, go ahead and expand it and factor it. Go. Okay, so it came out to be 3a plus 5, 2a plus 5. So if you didn't get that, maybe go back and look at your work. Pause it right now. We're going to move on to the next page. We're going to do some assignment from this. And your teacher will tell you more about that in just a bit. So we're actually on day 2 of factoring notes. And we have already practiced some, and I want us to do another one. So let's look at this one right here. We're going to factor this. So we take a times c, 1 times 9, that gives us 9. And we're going to put that up at the top of our x. We put a 6 at the bottom. We've been doing this. 1 and 9, 3 and 3. So my top number is positive. So AC is positive, so my signs are the same. They're the same with whatever B is, so they're all positive. So which pair am I going to use? I'm going to use 3 and 3. When I expand it, I'm now going to factor out greatest common factor, which is x. Greatest common factor, which is 3. So I get x plus 3, x plus 3. So what's in the parentheses is exactly the same. If that ever happens, we have to write it as x plus 3 quantity squared. Okay? Now, this, might have noticed, is a perfect square trinomial. Okay? This was a perfect square trinomial. I know that because I can look at it here, but because when I factored, I get this. If I ever have two binomials that are the same, you must make sure you write it as a quantity squared. Which is what we did right here. Okay, let's look at this one right here. So we're going to do that same thing, 25 times 9. Pull out your calculators. 25 times 9, and we get 225. We're going to put that at the top of our x. We negative 30 down here. Factors of 225. Who wants to list them? Nobody, exactly. So let's look at what we have. We have that the top number is positive, so my signs are the same. They're all going to be negative. So if they're all going to be negative, then that means that I have to find something that they're both going to be negative. Okay, so look at 225. 5 goes into it 45 times. Okay, so pause for just a second. So at first glance, it seems like, oh, that's perfect, 45. We're going to take 5 minus 45, no. But remember, we have to add. Those signs are the same. So we're going to have to find two numbers. Okay, the signs are the same. We're going to have to add to get 15. Add to get 30. Sorry, just kind of gave it away. So you might recognize that 225 is a perfect square. If I take 225 divided by 15, which would be the other number I'd try, I get negative 15. Negative 15 plus negative 15 is negative 30. Okay, so if it's a perfect square trinomial, I'm going to tell you about a shortcut on the back in just a second. But if you're ever looking at these and you have to add, if this is a perfect square up here, that's probably telling you, so you can just take the square root. So look at this, 225. I'm going to take the square root of that. And I get 15. So check to see if it's a perfect square from now on, too. That might save you a little work. Okay, so it's negative 15, negative 15. Okay, go, do the rest of it on your own. So you would have come up with 5x minus 3 in both parentheses. And this is what I'm talking about. If you ever come up with that, you have to write it as a quantity squared. So you write it once with a squared term on it. And again, this is a perfect square trinomial. So perfect square trinomials is one special case. We also had another special case. And like it says, special cases are done can be done the same way, meaning you can make an x. And then it will also show you what the shortcuts are on the back of this page. So the other special case besides a perfect square trinomial was a difference of squares. So let's talk about how we do it. Notice if we only have two terms, what about the middle term? Well, the middle term is missing. So what does that mean the middle term is? It's 0. Okay, so when we make our x here, our middle term is going to be 0. When I'm going to do everything else the same. 4 times negative 9 is a negative 36. That goes up at the top. Okay, but look at this for just a second. We're going to look at the factors of 36 in pairs. Two numbers have to add together to give me 0. What two numbers can add together to give me 0? Well, they have to be the same number and opposite signs. Okay, so we're still going to look at 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so we know it's going to be 6 and 6. Since this is negative, we know our signs have to be different. Does it matter which one's negative? No, it does not. It does not matter whatsoever. So I'm going to put the negative here, just because then I don't have to factor out a negative later. So I'm going to put the negative as my first one. Okay, but do you see, we don't have to worry about which one's positive or negative, because one of them has to be negative. It doesn't matter which one. Okay, so we're going to write that out in expanded form. We're going to factor by grouping. Take out a 3. And had I written it opposite here, I would have had to take out a negative 3. And that's what I'm saying by it doesn't matter which way you do it. It will work itself out. Okay, so 2x minus 3. So we get 2x minus 3. That's what's in parentheses. And then what we have left is 2x plus 3. Yes? So this is a difference of squares, and you'll remember same terms but opposite signs, okay? So let's look at number 6. We're going to do it the same way. We have a middle term that is 0, 49 times 36. That's the reason this shortcut is going to be so much better. But I'm going to tell you another thing you can watch for. 49 times 36, if you don't want to do the shortcut, is we get 1764, negative. So negative 1764. We definitely do not want to do all those factors. But here's the thing. We know that the numbers have to be the same. If the numbers have to be, they have to be exactly the same, just opposite signs. So therefore, this is a perfect square. So we don't list the factors. We just find the square root of it. So take your calculator, takes the square root of 1746, and we get not that. That's because I transposed my number. Sorry about that. It's 1764. Square root of 1764. Now that is a perfect square, and we get 42. Okay? So one of them's positive, one of them is negative. I'm going to make this one negative so I don't have to factor out a negative. So I have 49x squared minus 42x plus 42x minus 36. Go, you solve it, you go. So by factoring it, you would have found out that it was 7x minus 6 and 7x plus 6. Okay, let's look at the shortcuts. Now the shortcuts, we're going to look at difference of squares first. Difference of squares is this one I use. I use this one all the time because it's way easier. Even though I just showed you, it's pretty easy to do a difference of squares. You're going to identify first. So, two terms. You only have two terms. Both have to be perfect squares, and there has to be a minus or a negative sign. You can do it with a negative. Usually we're going to see it with a minus sign. And then here's a shortcut on how you graph. On how you factor. We're not going to graph this right now. Okay, so now we're going to do this example as we step through it. Make two sets of parentheses. Write in two different signs. Write in different signs. Take the square root of each one and put it in respective places. So the first term, square root of 16x squared is 4x. Square root of 81 is 9. And we're done. Okay? So on this one, we just have to identify on both of these. Usually the identification is harder than actual factoring if we remember how to factor. Okay, so here we go. And everything is 2. If I have two terms, I'm going to have two sets of parentheses. I'm going to have two different signs, and then I just take the square root of each of them. Yes? Okay? Now, number 2, I know it looks like you should rewrite it, but don't. Okay? Pause, try it, go. So hopefully you tried this on your own. I have two terms, so I'm going to have two sets of parentheses. I'm going to have two different signs, and I'm going to take the square root of the first term and square root of the last term. And I'm done. Okay? Look at number 3. Do I have two terms? Yes, I do. But I have a plus sign and no minus. I cannot factor this one. This one is prime. Now, you'll notice on these, see how this one's not in standard form? Sometimes that will happen. Usually we have to have them in standard form. We'll talk about that in the next lesson. But I'm not going to rewrite it. If my minus sign is here, it makes it a little easier. Okay? This one is not factorable or prime. Now, perfect square trinomial, I don't use this shortcut as much, because it sometimes takes more time unless I get really big numbers. So, identify. First and third, 3 terms, because it's a trinomial. Hello, trinomial, 3 terms. First and last term have to be perfect squares. The middle term has to be the square root of the first, so that would be 5x, times the square root of the last, that would be 7, times 2. You might remember when we did the shortcut, we're just doing the reverse. So 35 times 2 is 70x. So, and the last sign is a plus. This one has to be a plus in order for it to be factored this way. We can factor it. Now the shortcut is awesome. Okay, we make one set of parentheses. Well, first we rewrite this problem. This should be an x squared. Okay, let's identify. First and last term perfect squares, yes. This sign is a positive. So now I'm going to take the square root of the first, x, times the square root of the last, 4, times 2, gives me 8x. Yep, it works. So, to factor it, I make one set of parentheses. I put a squared on it. I take the square root of the first term, square root of the last term, and whatever the sign is, the first sign is going to tell me what my sign is that has to go inside. Okay? So here we go, number 2. Is it a perfect square trinomial? Well, this is a perfect square, yes. This is a perfect square, yes. Okay, so now and this is a plus sign. I'm going to take the square root of the first, 3x, times the square root of the last, times 2. Whoops, square root of 4 is not 4, it's 2. Sorry about that. So the square root of first is 3x, square root of the last is 2. Then I have to multiply it by 2. That's the rules. Okay, multiply it by 2 in order to find out. 3 times 2 is 6, times 2 is 12x. So yes, this one's also factorable. So try that one. Factor that on. So we know it's one set of parentheses and it's squared. We take the square root of the first term, square root of the last term, and do a plus. So the one thing you might want to do is check to see if there are big numbers, you might want to see if they're both perfect squares. Check to see if this is a perfect square trinomial. Otherwise, just skip on over it. Okay. The assignment that was to go along with square roots is this right here. So I would like you to do some, but the assignment that I think is probably most important is this one right here. Okay, this one you're just going to factor out the greatest common factor. That's all you're going to do. Just take out the GCF. That's all you do, which is great practice for the next lesson. Then this one you're going to factor completely. Don't worry about that, just factor. And this one gives you 4 terms, it gives you 2 terms, it gives you 3 terms. Okay, so this gives you lots of practice. So check with your teacher as to what your assignment's going to be, because we have lots of worksheets we've just gone through. Check with your teacher and see what we're going to have you do. Okay, great. So thank you very much. If you have any questions, you know where to find me.